So once tell me what we discussed in the last class. Concentration terms, then solubility. Before the solubility, again particularly about Henry's law, we have more concentrated, right? So what is Henry's law? Once tell me. Solubility of a gas are directly proportional to mole. Solubility of a gas is directly proportional to partial pressure of that gas. Okay, from this what we have derived one equation, P gas equals to P of that gas, partial pressure of that gas equals to KH, Henry's constant, mole fraction of that gas. Okay, this is what we discussed and we have solved some questions on this. Okay, so this Henry's law is at particular temperature, at constant temperature. Okay, if we change the temperature, solubility of gas also changes. Okay, so at a particular, like if I increase the temperature, what happens to solubility? Solubility decreases. See, there is something called Henry's constant, no? So with increase in temperature, what happens to the value of KH? KH also increases. If KH increases, what about its solubility? Solubility decreases. Done with this? Okay. Yesterday we solved some questions also, and after that we discussed about ideal and non-ideal solutions, if you remember. Okay. So how can you identify ideal and a non-ideal solution? What? If the intermolecular forces them are almost similar, then we can say it forms an ideal. Okay, and that obeys Raoult's law. So what is Raoult's law? We will discuss today. Okay, and if they are not obeying Raoult's law, or if the intermolecular forces between them are not same after mixing, then we can say non-ideal. Okay, non-ideal solutions again two types, positive and negative. Okay, done with that. So now today we will be discussing, so for an ideal solution, is there any change in heat after mixing? Any change in volume? No. Change in volume 0, change in heat 0. For which one? Ideal. For non-ideal, there will be some change. Okay, right. Okay, so now do you know what do we mean by vapor pressure? Vapor pressure means, see, let us say water is in liquid state. Okay, so now what you will do, you will heat it up up to at a particular temperature. Specifically, if I want to mention for water, it is up to 100 degrees you will heat it. Okay, now what happens, water will start converting into water vapors, right? Now water vapors. Now at this 100 degrees there is an equilibrium is established between the water vapors with its liquid. Okay, so this temperature, this particular temperature is called what? Boiling point of that particular liquid. Okay, here I am saying water, boiling point of water is 100. So at 100 degrees, what is the equilibrium you are going to see? There will be a equilibrium between liquid, water liquid state plus water vapor phase. Okay, is this clear everyone? Okay, so now see, vapor phase means it will be in the vapor phase, or I can say gaseous phase for a better understanding purpose. Okay, see, what do we mean by vapor pressure? Okay, see the pressure, see if this is a container, so it contains a liquid water here. What it contains? Water in liquid state. Okay, now you are heating this. So now what it will do? It will slowly converts into water vapors. Yes or no? Okay. Now look at this. At what temperature this phenomena will be observed? At 100 degrees. That is what the boiling point we are saying. Okay. So now the pressure exerted by these vapors over the surface of that liquid is considered as vapor pressure of that liquid. Once again, what do we mean by vapor pressure? The pressure exerted by the vapors of a liquid on its surface is called so once read, it is the pressure exerted by the vapors on the surface of the liquid at equilibrium between the vapors and the liquid. So that pressure is considered as what? Everyone clear what do we mean by vapor pressure means? Okay. So at this equilibrium state, see this is an equilibrium state now. Like what is the equilibrium? Here we are having water in physical state, liquid, here is in vapor. So now conversion of liquid to vapors is called evaporation. Conversion of vapors to liquid is called condensation. So at this condition, rate of evaporation and rate of condensation are in equilibrium, or they are equal. Rate of condensation equals to rate of evaporation. Okay. So now what are the factors affecting this vapor pressure? What is the next point we need to study? See, basic definition of vapor pressure is clear. Next, what I am saying, what are the factors that affects this vapor pressure? See, because some compound, some molecules or some solutions exhibit more vapor pressure, some are less. That is what we are saying, volatile and non-volatile. If you see, volatile means what? They will easily convert from liquid state to vapor phase. If they are easily converting from liquid to vapor, means they will exhibit more vapor pressure or not? Yeah. So now what we need to look, the intermolecular forces between the molecules. See, which liquid I am talking about here? Let us take that water molecules like this. This is one water molecule, second, third, fourth, like this. They are in the liquid state. Which state? See, if between these two water molecules, there is strong attractive forces between them. What do we mean by intermolecular forces here? Strong attractive forces between them. Now, liquid converting into gas means how the particles should be? Are they close or they should be far from each other? It means the energy or the temperature required to separate them will be more when the intermolecular forces are more between the molecules. Yes or no? So, more intermolecular forces, lower will be the vapor pressure. Can I say like that? Why I am saying like this? Tell me once again. If intermolecular forces are more, they will be in the liquid state only. Yes or no? So, the energy required to separate them will be more. That's why their boiling point will also be more. So, what I am saying, if more intermolecular forces, then what about its boiling point? Boiling point is more now. So, boiling point also more and vapor pressure will be less. Yes or no? Is this clear what I am writing this final statement? Okay. So, now tell me, there are two liquids. One liquid with boiling point of 50 degrees Celsius and second liquid with boiling point of 100 degrees Celsius. So, which will show more vapor pressure? Because intermolecular forces are less here, easily converts from liquid state to vapor phase. So, more vapor pressure. Is this clear everyone? Okay. So, now you just look at here, the final conclusion I will give you. So, what I told you, nature of the liquid. If the intermolecular forces are high, low is the vapor pressure. So, you can simply write like this, vapor pressure inversely proportional to intermolecular forces. Will you agree with this relation? Yeah. Take this fast. Only this one is enough. Just try to conclude, don't write all the theory part. That is for your reference. If you want, you can verify them later. Okay. Now let us see one example on this. Done with this? Yeah. Next. So what is the relation I have given? Vapor pressure inversely proportional to So now I am giving you 4 liquids like this. How many liquids you are seeing? 4. So where do you see more intermolecular forces? See, first of all, when you are considering intermolecular forces, do we have anything like electrostatic force of attractions between them or hydrogen bonding in the molecule? You need to check for that. See, if the molecule is polar, like H2O is there, so this bond get polarized or not? Like H plus OH minus like this, O minus like this will get now. So between the 2 water molecules, you are going to see what? Hydrogen bonding you are going to see. So there is intermolecular force. See, inter means between two molecules. If force of attraction is there, that is intermolecular forces. See, between these 2 water molecules, hydrogen bonding is there or not? So it means that's why water is having more boiling point when you compare with the hydrogen sulfide. See, H2O, sulfur, oxygen belongs to same group or not? But water exists in liquid state, H2S exists in gaseous phase. Which phase? Gaseous. Water exists in liquid, whereas H2S gas. So what is the reason for this? Here hydrogen bonding is present and there is no hydrogen bonding in this. So due to intermolecular forces, that hydrogen bonding only, water is in liquid state. Clear everyone? Okay. So now look at here, at a particular temperature, I am giving you 4 compounds like this. So where do we have more polar groups? See, if you observe, 3 OH groups are there here. Okay, so they can make hydrogen bonding. See, make a liquid ichchanante oka beaker lo, there will be lot many molecules like this. Water, half liter water ichchanante enno molecules untayi kada, water molecules like that. So there will be n number of this kind of molecules. Glycerin this is. So between two molecules there will be hydrogen bonding or not. Like that, between the molecules, more number of hydrogen bonding, more intermolecular forces, less vapor pressure. Yes or no everyone? Okay. So like this, you tell me what is the vapor pressure, which one is highest one? 4th. After 4th, 3. After 3, between these two, here water is there now. So both sides it will make hydrogen bonding. With this hydrogen, with this hydrogen, with this oxygen. Okay, that's why water will be greater than the alcohol here. So 2, 1. Clear everyone what we are doing here? So simply based on what? Intermolecular forces. So what I can write? Vapor pressure inversely proportional to intermolecular forces. Already you have written this. Based on this you have solved this. Okay, done with this? Okay, let's move forward. See, here HF, if you compare HF, there is more electronegative difference between fluorine and hydrogen. Yes or no? Which is highest electronegative element? Between fluorine and chlorine, fluorine is highest. So it will get a partial negative, partial positive. Here also partial positive, partial negative. But that polarity will be more in which case? HF case. So that's why it makes a very strong hydrogen bonding. What it makes? A very strong hydrogen bonding. But that kind of hydrogen bonding is not possible in between HCl molecules. ఇప్పుడు రెండు HCl molecules మీరు తీసుకున్నారు అనుకోండి, between them hydrogen bonding is not present. What I am saying? Hydrogen bonding is not present. That's why HCl, pure HCl will be in the gaseous phase. Which phase? So there is only dipole attractions but not hydrogen bonding, because hydrogen bonding is stronger when compared with this dipole. So it is present only in HF. So that's why what happens to this will be having more intermolecular forces, means low vapor pressure. This will be low vapor pressure, this will be clear everyone with these two examples. Okay, done. Let's move forward. Okay, so the first thing is what I have considered, intermolecular forces. So if intermolecular forces are not dominating, what we need to look for? We need to look for their molecular weight or the size. Bigger the size, see, this is one big molecule, another big molecule like this. Okay, this is one small molecule, this is also one small molecule. See, there is no intermolecular forces, attractive like hydrogen bonding, nothing is there. Now see, if there is big molecules, this is big, this is big, do they have more surface area in contact or not? Contact, ఇప్పుడు area of contact చూడండి, ఇట్లా పక్క పక్కన పెడితే they will be more close, but here they are occupying very less space right now. So that's why more size or more molecular weight, more is the intermolecular forces. First thing is like any polarity is there or not, you need to check. Second thing is sizes. Okay, if size, bigger size, more intermolecular force. Okay, now why I am saying this? Because if you observe these molecules, HF, we know hydrogen bonding is there between HF molecules, but for these halides no hydrogen bonding. Okay, so they do have only dipole interactions, but for this molecule hydrogen bonding. So definitely what we know to get to know from here, intermolecular forces are highest in HF, but there is no hydrogen bonding here now. So what I told you to consider now? Size. So which is bigger size here? HI is bigger size now, so more intermolecular forces here. So first HF, next HI, next HBr, least HCl. So more intermolecular forces, vapor pressure. So less vapor pressure is for which one now? Less vapor pressure is for which one now? HF. That's why it is least. Okay, clear now? Opposite of that order you will get here. Clear or not what we are discussing? Okay. Write that. Next, effect of temperature. So what I am saying, effect of temperature. For example, you have a liquid here. Okay, so you are heating or you are raising the temperature of this. What happens, that liquid converts into vapors or not? So with increase in temperature, vapor pressure also increases. Can we say like that? So vapor pressure increases with rise in temperature of the liquid. Okay, because kinetic energy of the molecules increases, therefore molecules leave the surface and converts into vapors. That is the story. You just mention effect of temperature you put, and if temperature increases, vapor pressure also increases. You just write it like this. Okay, then next, exactly the relation between temperature and vapor pressure is given using this Clausius-Clapeyron equation. What is that equation called? Clausius-Clapeyron equation. So what is this Clausius-Clapeyron equation? See, at a temperature T1, vapor pressure I am saying it as P1. What I am saying, at temperature T1, what is the vapor pressure? P1. At temperature T2, vapor pressure also increases now, it becomes P2. Okay, so log P2 by P1 is equals to delta H by 2.303 R 1 by T1 minus 1 by T2. Write it like this. What is the Clausius-Clapeyron equation? Log P2 by P1 equals to delta H 2.303 1 by T1 minus 1 by. So at temperature T2, what is the vapor pressure? P2. Temperature T1? P. Okay. So effect of temperature, you write this, then directly write this equation by keeping it as a Clausius-Clapeyron equation. Done? Okay, remember this equation, we will again look into this in chemical kinetics. Okay. Okay. See, once read these lines, already we discussed. Vapor pressure increases with the rise in temperature. For a given set of two liquids, vapor pressure is more if boiling point is less. Yes or no? So I am giving liquid A, B with boiling point 100 and 120. So more boiling point, less vapor pressure. So less vapor pressure. Clear everyone? Okay. So you can directly write this example. Okay. Done up to here everyone? See, boiling point is more means what does it mean? Energy required to convert this liquid into vapors is difficult. It means more intermolecular forces are there. So if more intermolecular forces are there, they will be in the liquid state only. They won't convert into vapors. Right now? Yes or no? So more boiling point, low vapor pressure. Okay, done. Over up to here everyone. Next, see, Raoult's law we are discussing. What we are discussing? Raoult's law. So what is this Raoult's law says? For a solution of volatile liquids, for what? For a solution of volatile liquid, the partial pressure of a component is directly proportional to the mole fraction in the solution. It means, see, you are making a solution. A, B are the two components. Use it to make a solution of AB. Okay, consider B as a solute, A as a solvent. What I am saying? B as a solute, A as a solvent to make this solution. Now, what is a, see, volatile solution, these both of them are volatile I mentioned. Then solution also volatile now. Okay, We don't know whether it will be more volatile, less volatile than their components, we don't know, but this is also having volatility or not? Yes. So now what I am saying, in the solution, we have A and also we have B, yes or no? So the vapor pressure of A is directly proportional to its mole fraction in the solution. It means, let us say I am adding 1 mole of A, 1 mole of B to make this solution. Okay, now what is the mole fraction of A in the solution means, what is your formula? Mole fraction of A is equals to number of moles of A by total number of moles, that is Na plus Nb, yes or no? How many moles of A I have added? 1 mole, B 1, so total 1 by 2, like this. So the vapor pressure of A in the solution, what I am making? Vapor pressure of A in the solution is directly proportional to its mole fraction in the solution. Similarly, tell me for B, vapor pressure of B is directly proportional to mole fraction of B. Okay. Now listen here carefully, very easy Raoult's law, and you can expect one question on this. See, component A is a volatile now. If it is volatile, will it show some vapor pressure or not? So I am saying the vapor pressure of pure A, that is P naught A. What do we mean by P naught A? Vapor pressure of pure component A before mixing. See, na daggara 2 beakers unnai. Beaker 1 lo emundi A, beaker 2 lo B. I have taken them separately. Okay, so when I taken this A, what is its vapor pressure? P naught A, because it's a pure form now, that's why I am putting it as not. P naught B for this pure B. What is P naught A? P naught B represents vapor pressure of A and B in their pure states. Okay, now I am mixing them to make the solution. Okay, now I am mixing them to make a solution. Now what is the vapor pressure of A in the solution I am asking? That should be represented with what symbol? PA. So meeku difference ardhamainda, what is PA, what is P naught A? PA means in the solution vapor pressure of A. P naught A means pure form, vapor pressure in the pure form. So now what I am doing here, you just see what I am doing. PA is there now, so I am writing PA is equals to, I am remove this proportionality, just assume like that. So I am writing here P naught A chi A. What I did, vapor pressure of A in the solution will be equals to vapor pressure of that pure component with multiplied with its mole fraction. Similarly, PB, tell me here, PB equals to P naught B chi B. Is this clear? Okay. So now Raoult's law applicable only for ideal solutions. Which solutions? So now I am asking, then what will be the total pressure of this solution? What I am asking? What will be the total pressure of this vapor pressure of this solution? That is P total or PS is equals to PA plus PB. Can you write like this? Okay. So PA is how much? P naught A chi A plus P naught B chi B. Is this clear everyone? Are you following this or not? Okay, PA means what once again? Vapor pressure of A in the solution. PB means vapor pressure of B in the solution. Okay, up to here everyone clear with this? Okay, make these formulas. Make these formulas. I will give you some direct questions so that you will feel more confident about this concept. Don't write too many things, just write these formulas, it's enough. Or you can make a one single line statement in your own language. So if someone asks you what is the Raoult's law means, what do you say? This one. P total equals to vapor pressure of solution equals to PA plus PB. Again, what do we mean by PA PB means? P naught A chi A plus P naught B chi B. Okay. Done up to here everyone? Yes. Next. So A, B are what? They must be what? Volatile. What they should be? Volatile. Then up to here. Okay. So what we have written finally, P total equals to P naught A chi A plus P naught B chi B. Okay. See, sum of mole fractions chi A plus chi B, XA plus XB equals to 1 we are writing now. So instead of writing chi B, what I am saying is chi B is equals to 1 minus chi A. Can we write it like this? No issues now. So wherever we have chi A, there I am placing this one. Do you have any issue with that? No. So I am writing that here. Okay. Try to multiply this inside. It becomes P naught B minus P naught B chi A. Yes or no? Yeah. So from this, finally you can make an equation like this. Ikkada idi chudandamma, we can write it like this. So now if you observe, here chi A is there, here chi A is there. So can I take it as a common? So it becomes P naught A minus P naught B chi A plus this single P naught B. Okay. So now what we are going to get here, why we have made like this, we are going to get a graph here. So for that purpose only I have made it. Okay. So again, look at this. What is PA means? What you will write? P naught A chi A. Similarly, PB means? Like this you are writing now. So let us see one graph from these two lines itself. See how it is? Y is equals to mx type of graph we will get or not? Okay. Like this I am writing. So here I am saying mole fraction of A is equals to 1. What is the mole fraction of A I am saying? See, this is the origin now. So at this origin, what is the mole fraction of A? 1. It means, what does it mean? Tell me. Idi ante enti? Mole fraction of, see, sum of mole fractions should be equals to what? 1. I am saying chi A itself 1 means chi B will be? Chi B will be? Total sum is 1. I am saying its value itself as a 1. Then chi B becomes how much? 0, no? So you can write chi B will be equals to 0. Ante, ee line dagara, we have only one component. What is that component? A component or B component? A component. So it means whatever the pressure you are seeing here, that pressure is shown by what? Ikkada pressure, whatever the pressure you are measuring here, that complete pressure is given by what? A only, na, because B component is not there here. So I am saying this is the pressure exerted by A. So that is nothing but only A is there now, pure A is there means what is this vapor pressure? P naught A. Okay. So I am going like this, like this, like this, like this. I have reached a point here. Okay. So at this point, what I am saying, my chi B equals to 1, then chi A becomes 0. Yes or no? Okay. So it means on this line, what do we have now? Only B. Okay. Now the whatever the vapor pressure you are measuring, that is exerted by what? B only now. So that is nothing but B. P naught B. So I am writing here P naught B. Clear up to here everyone? Clear or not? Okay. See, y equals to mx means how can I draw a graph? Something like y equals to mx. Something like, see, y equals to mx and itlane kada rasenu. This meeku telusa graphs giyadam. Y equals to mx means like this only now. So it means it starts from here, like this it will goes. Okay, for A graph. Okay, for B graph, I mean for that one, like this it will comes. Okay, now if I ask you total pressure, what you need to do? You just join them like this. So this line says about total pressure. This line says about, see from here to here now, so it says about PA. This line says about PB. Clear or not everyone? Which line is for what? Okay, so this is the graph. When this is the graph we will be seeing if it is an ideal solution. Which solution? Ideal solution. Then we have studied about non-ideal solutions now. Non-ideal solutions are two types again, positively deviated, negatively deviated. See, if I say positively deviated, its vapor pressure will be more, so you are going to see a line like this. If I am saying negatively deviated, this is for which one? This line is for which one? Ideal. This is for ideal P total. Okay, this line will be for which one? Total pressure for positive deviation. So if I want to change the color, yeah, pink will take. This line is for what now? So negative deviation. Is this clear everyone, how we are drawing the graphs? Okay, even here also you will get the lines. For each one, A, B also you will get the lines. Clear or not everyone? How to identify positive deviation, negative deviation? Okay. See, again, yesterday I told you, positive deviation, when it will be seen in the, like positive deviation means, what happens to intermolecular forces? After mixing, what happens to the intermolecular forces? When I say positive deviation, intermolecular forces decreases. Intermolecular forces decreasing means what happens to vapor pressure? Kada? Positive deviation means, see that line is above side. Above side means its vapor pressure is more or less? More. So more vapor pressure means less intermolecular forces now. So that's why this is for positively deviated solution. Okay. If I say negative deviation, intermolecular force after mixing more or less? More na. So more intermolecular forces, less vapor pressure. So that's why this line is coming downside. Is this clear everyone? Okay. So draw this graph with this whatever the equation you have written, beside that you draw. See, there are some questions also on this. Later you can solve. See, in the page number 20 you have some question, 1 or 2 questions are there. You can solve later after the class. Done up to here? This graph, just draw the graph. Done up to here everyone? This graph itself, last graph. ఈ లైన్ ఏం చేస్తుందో అర్థమైందా? ఈ లైన్ ఇట్లా కిందికి వచ్చింది చూడండి. See, here we have only A component. As we go from here to here, what happens to A mole fraction? అంటే ఇక్కడ mole fraction change అవుతున్నట్టమ్మా. See here, maximum mole fraction is there. Means if I go from this side to this side, mole fraction is becoming 1. Here it is 0. So from this side to this side, what happens to chi B? 0 to becoming 1. This side chi B is increasing, chi A is decreasing. So here almost chi A is 0 means then there is no component A. If no component A, its vapor pressure becomes 0 only, no? So that's why it is touching origin here. Okay. Clear up to here this graph? Next. The next. Vapour-Raoult's law graph followed only by ideal solutions. For non-ideal solutions, what happens? Line becomes upside or downside. Okay, they deviate from the ideal behavior. So now, how to identify these ideal solutions? What I told you, the solutions which obeys Raoult's law at all compositions, solute and solvent at all temperature is considered as ideal solutions. Yesterday we discussed already, they should follow these two things. I mean, Raoult's law they should follow. Delta H mix should be equals to 0. Energy change should be 0. Okay, volume mix should be total volume change should be 0. It means 0 means what? 20 ml of A, 20 ml of B if you add, you should get only 40 ml. It should not be like 39 or it should not be 41 like that. Should not be less, should not be greater. Okay, so this is what delta V mix 0 means. Okay, then next one, for it can be for ideal, non-ideal. Delta S always greater than 0. What I am saying? It can be for ideal, non-ideal. Delta S mix should be greater than 0 and delta G mix should be less than 0. So because these are spontaneous processes. For a spontaneous process, delta G should be negative, delta S should be positive. Okay, write these conditions. Okay, we have direct questions on these conditions, that's why I am giving you. So again, intermolecular forces between molecules before mixing and after mixing, they should be almost similar. Okay, right. Done these 4 points, 4 boxes you write. Over. Okay. So now see, benzene, toluene, N-hexane, N-heptane, all these are examples for what? Ideal. Yesterday itself we have written for these things. Next, non-ideal solutions. Non-ideal solutions, they do not obey Raoult's law we discussed. Okay. So now what are the conditions I told you? Delta H not equals to 0. These things. Okay. I will show you. Wait. Here we have. So positive and negative deviation. Okay. See. That vapor pressure you have seen now, for ideal how it is, like this we are seeing above side. So it means P observed, it means if we do it from the experimental, that value is greater than theoretical calculation. It means it is showing what type of deviation? Positive. See, మనం Raoult's law equation యూజ్ చేసి క్యాలిక్యులేట్ చేసామనుకోండి, ఒక వాల్యూ వస్తుంది కదా, ఆ వాల్యూ కన్నానంట క్యాలిక్యులేటెడ్ వాల్యూ అంటే ఎక్స్పెరిమెంటల్ వాల్యూ అనేది ఎక్కువ వచ్చింది అంటే ఇట్ ఈస్ డీవియేటింగ్ ఫ్రమ్ Raoult's law ఆర్ నాట్? ఇట్ ఈస్ డీవియేటింగ్ ఫ్రమ్ Raoult's law విత్ బిగ్గర్ వాల్యూ ఆర్ స్మాలర్ వాల్యూ? బిగ్గర్ వాల్యూ మీన్స్ పాజిటివ్ డీవియేషన్ ఆర్ నెగిటివ్ డీవియేషన్. దట్ ఈస్ వాట్ దిస్ లైన్ సేస్. Okay, so here the value, calculated value and observed value is like this. So it means it is a negative deviation. Okay, that's it. Next, see, observed means by doing some experiment, real experiments. Calculated means theoretically using a Raoult's law. Okay, so now what are the conditions for positive deviations? I told you enthalpy change greater than 0, V mix also greater than 0, delta S mix also greater than 0, but delta G mix should be negative. Delta G mix is negative for all the processes, can be ideal or non-ideal. Delta G అనేది ఎలా ఉండాలి? Negative, because it represents a spontaneity of a process. Delta S ఎలా ఉండాలి? It should be always positive for any mixing, ideal or non-ideal. Okay, so only two things you will be seeing is V mix, H mix. What are the things you are seeing different? There it will be 0, here it will be positive, here it will be negative. Write these conditions only. In the yesterday slides you can write. Okay, this is more than enough. Let's solve one or two questions. Over up to here, everyone. Read this first question which is written with black pen. Yeah, read it once. The vapor pressure of pure methanol is this much. How much it is? 0.15 at 25 degrees Celsius. The vapor pressure of this liquid in which solution is with the liquid B is 0.09 bar. Okay, calculate the mole fraction of B. Once again read the question, what they are saying. Try to understand the data provided. vapor pressure of pure methanol. It means what is the indication for that? P naught of methanol. How much? 0.15 bar. Next. The vapor pressure of this liquid in which solution with liquid B is this much. It means what this number indicating? What? Is this a pure one or solution one? Solution one means how should we represent? Just a P of what they are giving. See, the vapor pressure of this liquid, it means which liquid? Methanol, in which solution with liquid B. It means a methanol and liquid B is added to make a solution. In that solution, vapor pressure of methanol is how much? So this is P of methanol in the solution. Vapor pressure of methanol in the solution is how much? 0.09 bar. Is this clear up to here? Now what they are asking? Calculate the mole fraction of B. See, even if I know mole fraction of A, I can able to calculate mole fraction of B because their overall sum is equals to 1. So if I know mole fraction of methanol, I can able to calculate mole fraction of this liquid B. Yes or no? Okay. So now tell me, what is the relation that gives you between P and P naught? Partial pressure of a liquid A is equals to P naught A chi A. It means like partial pressure of methanol in the solution is equals to mole fraction of methanol multiplied with its pure pressure, pure vapor pressure. So what I can write? P of methanol is equals to P naught of methanol multiplied with mole fraction of methanol. Yes or no? So from this I can get mole fraction of methanol. How much? This one by this one. P by P naught. Yes or no? Ardhamautunda? So tell me, what is the answer? What is 0.09 by 0.15? So I can write it as 9 by 15. Okay, how much it will be? 3 by 5. So how much you can say? 0.6. This is mole fraction of what? Methanol. So now mole fraction of other liquid, how much it becomes? 1 minus this value. Everyone got this? How we are doing? Okay. So try to write it in the fast, like do it fast. If you are making late, then I will skip some questions. So do it fast. Okay, done. Write a question, everyone. Don't write this. I will tell you which question to write. Done with this question? Okay. Okay. Right. 1 mole of benzene and 1 mole of toluene are mixed to make a solution at a temperature T. Then vapor pressure of solution is how much? Given vapor pressure of pure benzene is 100 mm of Hg and vapor pressure of pure toluene is 50 mm of Hg. Is that question is clear or not? First read it once. Everyone read the question once. ఏమర్థమైంది? చెప్పండి. Equals to PA plus PB. Now tell me what is PA PB values now. Like P naught A chi A plus P naught B chi B. Now we have P naught A P naught B values here 150. Okay, these values are there, fine. What about these values? Yeah, easy. From here 1 so do it and tell me. First find mole fraction. Chi A means what? Mole fraction of A. So consider this as benzene, this as toluene. Do it now. What is toluene's mole fraction? 1/2, because mole fraction of toluene, if I ask, number of moles of toluene is how many? 1. Total number of moles how much? 1 plus 1. So it is 1/2. Clear? Similarly, mole fraction of benzene is how much? 1/1 plus 1. So this is also 1/2. Clear up to here, everyone? So you put here the value as for the toluene first. So 50 into 1/2 plus 100 into 1/2. So this is total. So 25 plus 50. 75 mm of Hg. So what is this mm of Hg? This is also a unit to measure pressure. Unit to express pressure. Clear, everyone, how we are doing? Okay. One last model question here I wanted to give you. P total equals to P naught A like chi A plus P naught B chi B. Then next our equation in what terms? Chi B terms. So in the place of chi A I can write 1 minus chi B. So convert that P next P naught A ఇది సింప్లిఫై చేస్తే ఏమొచ్చిందో చెప్పమ్మా. P naught A minus P naught B into direct equation, final equation P naught B. Okay, so I will do here. See, P naught A minus P naught A chi B plus P naught B chi B. See what I can write this P naught A as it is. Okay, see in the equation you are seeing here minus now. Okay, so now what we will do? So minus chi B I can take as common. P naught A minus, done now. Compare this equation with this equation. So in the place of chi B is there. Beside that, how much value you have? So that 75 equals to this number. P naught A minus P naught B equals to how much? 75. Next term what we have? Here what we have? It means P naught A definitely 120. Clear everyone? Okay. Now P naught B how much it will be? P naught A minus 75. Can I write? So 120 minus 75. How much it will be? Okay, nimsham. P naught A minus P naught B equals to 75. P naught A is how much here? 45. Ante amma. So చూడమ్మా నీ క్యాలిక్యులేషన్స్. అమ్మయ్యా. Whatever you tried, it is correct. That's why I asked you. Okay, so everyone got this? How we did? రాలేదా? అర్థమైందా? Okay, done with this everyone? ఏమైనా కన్ఫ్యూజన్ ఉందో చెప్పండి. నెక్స్ట్. ఓకే, see, now what is happening is I have a liquid in this container. What I am saying, I have a liquid, like I have a solution which is made up of A and B. What are the things I have used to make the solution? A and B. Now let us say it is a closed container and it's a volatile liquid. Which type of liquid? So now what this liquid will do now? Some of this liquid will convert into its vapors. Yes or no? Yeah. So now if I say mole fraction of this liquid, how you will write? Mole fraction of A and mole fraction of B you will say. Right now? Similarly, if this liquid is converting into vapor means here also mixture of vapors will be there. In the mixture what are the things we have in the vapor phase? Same A, B, but in which form? Gaseous, vapor forms, right now. So that mole fraction is how much? It means Ya is how much? So what do we mean by Ya? Mole fraction of this A in its vapor phase or in gaseous phase. Similarly, for B what I should write? Yb. So why I am using Y and this Y things? Because here I used X now. X is for what? Mole fraction in liquid state. Then for mole fraction in gaseous phase means Y. That's it. Is this clear everyone? So what is the indication of Y here? Mole fraction in vapor phase. Xa means mole fraction in liquid phase. Now how can you calculate this value? That is what the question. Okay. So if you remember, you have studied a 2 marks question for your IPE in states of matter like Dalton's partial pressure, Dalton's law. Okay, so what it says, the vapor pressure of a liquid, like vapor pressure of an ith gas, sorry, let me give you here clearly. The partial pressure of an ith gas is equals to mole fraction of that gas into P total. Do you remember this equation anywhere? Have you studied this anywhere? No, you studied it in the class 11th 2 marks question. So what it is says, partial pressure of an ith gas is equals, ith gas means for a particular gas. See, I have a gaseous mixture. This gaseous mixture is made up of A, B, C, D, like this. Okay, so now what is the partial pressure of this gas A? If I ask, in the mixture, partial pressure of A is equals to mole fraction of that A into total pressure exerted by this gaseous mixture. So PA equals to chi A into so for gaseous, what I should use? Should I use Y or I should use X? Y. So you should write here as Y. Is this clear? So now tell me for this. Now PA becomes equals to YA into P total. Yes or no? So from this I want YA, PA by P total. Again, YB means PB by P total. Okay. Again, PA means what we have written? P naught A chi A. P total means what? P naught A chi A plus P naught B chi B. Clear everyone? Okay. So write these equations. What is the use of these equations? You are going to say vapor phase composition. What you are going to say? Vapor phase composition ante entamma. See, liquid state lo ఎలా ఉంది కాంపోజిషన్ అంటే మీరు ఏం చెప్తున్నారు సో మోల్ ఫ్రాక్షన్ ఆఫ్ ఏ ఈజ్ 1 మోల్ ఫ్రాక్షన్ ఆఫ్ బి ఈజ్ 1 లైక్ దట్ యు ఆర్ సేయింగ్ నా సో లైక్ దిస్ వాట్ ఇస్ ద మోల్ ఫ్రాక్షన్స్ ఆఫ్ ఏ బి ఇన్ ద వేపర్ ఫేజ్ దట్ ఈస్ వాట్ వేపర్ ఫేజ్ కాంపోజిషన్ మీన్స్ హౌ మెనీ మోల్స్ ఆఫ్ ఏ హౌ మెనీ మోల్స్ ఆఫ్ బి ఇన్ దిస్ వేపర్ ఫేజ్ okay, just write these equations, that's it. Okay, let's see one question. Not required. Done up to here everyone? Over? These formulas only. Okay, read the question once, what it is saying. Two liquids AB forms an ideal solution at a temperature T. When the total vapor pressure above the solution is 400. P total is how much? 400 tar. Okay. The mole fraction of A in the vapor phase is this much. It means what is that? YA is equals to how much? 0.4. And in the liquid phase is 0.75. It means XA equals to 0.75. What are the vapor pressures of pure A and pure B at this temperature T? Now what they are asking us, what is P naught A, what is P naught B? Okay, so how can you do this? P total they have given, and they given YA also now. Now what is the relation between these two things, tell me first. Yeah, so what I can write? YA is equals to PA by PT. Okay, now what happens to YA? YA we got PA. From that PA equals to YA into PT. Okay, So PA means YA value is 0.4, P total is 400. Again, PA means what I can write? P naught A, chi A. So from this chi A also I know how much it is? From that P naught A is equals to, send this here, 0.4 into 400 by chi A. So 0.75, 0.75. So now what I can do is, I am removing this 0 with this 0, 4 4s are 16. So it becomes 160 by 0.75 means, can I write 3 by 4? Okay, just for simplification purpose. So you take it reciprocal. That's it now? Okay. So just check, yeah, all of them are having some points means definitely will get. Yeah. So how much it will be? How much it will be? 5 is a, okay, how much? 53, 3 is a 9, 15. So it is around 53.3 something like that we'll get. Multiply this, 12, 1, 12, 13, 21. 213.2 anywhere we have? These two options are there. Is this clear up to here everyone? Clear or not? How do you finding? So P naught A is fine. See, if YA is this much, then what is YB? 1 minus YA. That is 1 minus 0.4. You'll get 0.6. Clear up to here? Okay? Khaleda? Okay. Next, if chi A is this much, chi B is how much? 1 minus 0.75. That will be 0.25. Clear? Same, itlane adi kuda cheyochu kada? Cheyarada. Same steps you follow, you will get P naught B also. Okay, will you do that? Okay, you can do later. Next. So you practice more number of questions, you can able to do them easily. Next one is, let's discuss about azeotropic mixture in the short form. See, what do we mean by azeotropic mixture? First of all, azeotropic mixtures are formed by non-ideal solutions only. What solutions? Non-ideal solutions only. Okay. So specifically, if you want to understand azeotropic mixtures, you can see here. Azeotropic mixtures are also called as constant boiling mixtures. What they are? Constant boiling mixtures. Okay. It means they behave as a pure liquid. See, just listen to me. I have two liquids, liquid A and liquid B. I have made a solution of this liquid AB. What I have made? Solution. So now, if you heat this, see this liquid AB, they won't react. They just add one another. That's it. So if you heat this, what happens? Might be the one component which has lower boiling point will converts into vapors. So if I separate that vapors, what happens? A and B got separated or not? Once again listen what I am saying. Na daggara liquid A, liquid B undamma. Vatni mix chestunna, so it will form a solution. So ee solution ippudu naaku em kavalante ee solution ni nenu separate cheyalanuntunna. Appudu em chestam? If you heat this, the one which is having lower boiling point converts into vapors. Lower boiling point unnademo vapors lo undi, higher boiling point emo liquids lo undi. Ee vapor nu ee liquid ni separate chese avi separate ayinatte kada. So this is what distillation process will say. What will say? Distillation. Now, when I say azeotropic mixtures, these are also mixture of two components. But nenu itla distillation chesanu anukondi, avi distill kavantam. They behave like an individual solution. How they will behave? Ante they will get a special property. Special property means you cannot able to separate that type of mixtures after boiling it. Okay, those kind of solutions are called what? So for example, you just see. So what I have taken is, I have used this composition. HNO3 and H2O, we have a mixture. Okay, so particularly at what composition? 68% HNO3 and 31% or 32% water. So this mixture, if you boil it out, they won't separate as water and HNO3. They behaves as an individual. ఇప్పుడు ఇది ఏమని చెప్పినా, if you heat this, what happens normally? The one which is having lower boiling point should vaporize, converts into vapors that can be separated out. Kada? This should be happens in distillation process. But when you take azeotropic mixture and if you heat it, complete mixture itself converts into vapors. Even in the vapors also same composition is there. అర్థమైందా కాలేదా? Normalగా if AB are there, if you heat it up, what happens? The lower boiling point converts into vapors so that we can separate out. But when I say azeotropic mixtures, even if you heat this, what happens? Converts into vapors, but that vapors also contains same composition. Liquid lo ela undo vapor lo kuda appudu can we separate them? No. So those kind of solutions are called what? Azeotropic mixture. అర్థమైందా కాలేదా? Okay, next, the best example is HNO3 plus water, this composition. Next one is ethyl alcohol plus water. See, yesterday's class we discussed. Tell me whether HNO3 and water forms which type of deviation, negative or positive? Negative deviation. So negative deviation ఎవరైతే చూపిస్తారో they forms maximum boiling azeotrope. What type of deviation they will form? Azeotropes they will form maximum boiling azeotrope. If they are showing positive deviation, they will form minimum boiling azeotrope. What I am saying? ikkada meer two names you need to remember. One is maximum boiling అంటున్నా, ఇంకొకటి minimum. Just keep it aside, concept keep it aside. Once again come back. Yesterday we discussed about negative deviation kada. What happens to intermolecular forces in negatively deviated solution? Intermolecular forces increase అవుతాయి కదా. If intermolecular forces are increasing, what happens to its boiling point? Increases. That's why the name is called as maximum boiling azeotrope. అర్థమైందా? Why we are calling them as maximum boiling azeotrope? Because intermolecular forces are increasing, therefore their boiling point of the solution also, so that's why we are calling them as maximum boiling azeotrope. Next, ఇంకొకటి ఏమంటున్నాం? మినిమం బాయిలింగ్ అజియోట్రోప్. సి పాజిటివ్ డీవియేషన్లో వాట్ హ్యాపెన్స్ టు ఇంటర్మాలిక్యులర్ ఫోర్సెస్? ఇఫ్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఆర్ డిక్రీజింగ్, దే కెన్ ఈజీలీ కన్వర్ట్స్ ఇంటూ వేపర్స్. అంటే బాయిలింగ్ పాయింట్ ఏమైంది? ముందు కంటే కంపేర్ చేసి ఇప్పుడు బాయిలింగ్ పాయింట్ తగ్గినట్టే కదా, బికాస్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఆర్ డిక్రీస్డ్. సో I can say which type of azeotropes it is? Minimum boiling azeotrope. Clear everyone? Okay. ఇక్కడ చూడండి, ఈ గ్రాఫ్ ఏం చెప్తుందో చూడండి. దిస్ ఈస్ ద బాయిలింగ్ పాయింట్ ఆఫ్ ప్యూర్ కాంపోనెంట్ A, దిస్ ఈస్ ద బాయిలింగ్ పాయింట్ ఆఫ్ ప్యూర్ కాంపోనెంట్ B. Now if you see this dot, at this dot particular composition will be there now, so this is azeotropic dot. What is this? See, ఈ డాట్ వీటి పైన ఉందా కింద ఉందా ఈక్వల్గా ఉందా? లైట్గా కిందకే ఉంది కదా, అంటే విచ్ టైప్ ఆఫ్ మిక్చర్ ఇట్ ఈస్? మినిమం బాయిలింగ్ ఆర్ మ్యాక్సిమం బాయిలింగ్? మినిమం బాయిలింగ్. సో మినిమం బాయిలింగ్ azeotropes are formed by positively deviated solution. Best example here is we have ethyl alcohol plus water system. What is that? Ethyl alcohol water forms which type of deviation and which type of azeotrope? Clear everyone? Okay, next, nitric acid. ఇది చూడండి, ఇక్కడ కంపోజిషన్ లేదులేండి. సో నైట్రిక్ యాసిడ్ అంటే ఎలా రావాలి చెప్పండి? దిస్ షుడ్ కమ్ సంథింగ్ లైక్ దిస్, అప్ సైడ్ నా లైక్ దిస్. ఓకే, యా, దట్స్ ఇట్. It is more than enough if you understand like this. Clear everyone? What you are writing, just write. Just write these two lines. Azeotropes are two types, minimum, maximum. Solutions which shows a large positive deviation forms solutions which shows large negative deviation. Write these two lines, this is more than enough. over. Next, one more important topic is there, ma. If you finish that, chapter is done, but it takes almost 1 hour time. Okay. Okay. Ardhamainda? What is this freezing point application? Depression in freezing point means? Yeah. So the next, first one is, what is the first colligative property we have? Relative lowering of vapor pressure. I am saying it in the short form as RLVP. See, name itself saying relative lowering. What is lowering? Vapor pressure. See, I have pure solvent. So let us consider it as a volatile solvent. What I am saying? Volatile solvent. So pure solvent, so it will be showing more vapor pressure or not, because it's a volatile component. Okay. To this, I am adding a solute which is a non-volatile. What I am adding? Non-volatile solute I am adding. See, if I am adding a non-volatile solute to make a solution, what happens to vapor pressure? Intaku mundemo volatile component okate unde, that will converts into vapors, shows more vapor pressure. Now what I am adding? Non-volatile solute I am adding. So now what happens? That non-volatile solute particles will be accumulating on the surface of this liquid or not? Like this, undeya. So now what it will do? It will lower the vapor pressure of the solvent. Will it lowers or not? So vapor pressure of that solvent or the solution becomes lowered. So can I say lowering of vapor pressure? So initially I have what? Only solvent is there now. So solvent vapor pressure I am saying it as P0. What is this P0 indicating? Vapor pressure of pure solvent. Now after adding solute, what happens? It forms a solution. So solution's vapor pressure I am representing as PS. What is this PS indicates? Solution. Vapor pressure of solution. So solution ki vapor pressure ekkunda solvent ka? Solvent ki. And you have decreased some vapor pressure na? So how much it is decreased? That is nothing but this minus this you can do now. P0 minus PS gives you lowering of vapor pressure. What is this lowering of vapor pressure means? P0 minus PS. Okay. So now what is the name of our topic? Relative lowering. It means how much it is lowered to the initial. So it means RLVP is equals to P0 minus PS by P0. It means to the initial case how much it is lowered. That is what relative lowering of vapor pressure. Is this clear? Okay. So this relative lowering of vapor pressure, RLVP, what is the formula you got? P0 minus PS by P0 will be equals to how much solute you are adding. That is nothing but mole fraction of solute. What is that? Mole fraction of solute. So finally what is RLVP formula to remember? P0 minus PS by P0 equals to solute, mole fraction of solute. Okay. So solute is volatile or non-volatile? Non-volatile. So when you add non-volatile component to the volatile component, what happens to the vapor pressure? Decreases. That is what this thing we are studying in the RLVP. Okay. That's it. You just write this final formula. Okay. So RLVP is a colligative property we are studying. Yes or no? So line, just listen this line. RLVP is what? Colligative property. See, I am adding a glucose particles now. What I am adding? Glucose particles. Let us say 1 mole of glucose I am adding. Will this glucose dissociate? It's a non-electrolyte now. Won't dissociate. So wherever you are, whatever the quantity you are adding, that many particles will be there on this surface. Okay. If I add same 1 mole of NaCl, now what happens? It will become doubled. It means it becomes Na plus 1 particle, Cl minus another particle. So how many particles it becomes here? 2 times. If I add 1 mole, it becomes 2 mole. Why? Because this is 1 particle, this is another particle. Kada? So if more the number of particles of these solute particles, lower will be the vapor pressure. Yes or no? So it means the type of particles you are adding deciding how much vapor pressure is lowered. Right now? So in order to adjust this, I am using a symbol I here. What is the use of I? It is said as Van de Graaff factor. What is that? Van de Graaff factor. What is the use of Van de Graaff factor? You are saying now how many glucose particles will come? 1 glucose particle. So I value is 1 for glucose. How many NaCl particles are coming? So I value is 2 for NaCl. So 2 into chi B it becomes. If I add something like CaCl2, how many particles it will be giving you? Calcium plus 2 plus 2Cl. So how many particles you are seeing? 2 plus 1. 3 now. So I value becomes how much? 3. So now what happens? RLVP equals to I into chi B you are saying. So it means 3 into chi B. Like that we need to take. Okay. Is this clear? Clear or not? What is mean by I? Okay. Colligative properties and ఏంటి basic definition ఏం చదివినాం? These are number dependent properties. ఇక్కడ numbers increase అయినా కొద్ది property value also changing now. That's why I introduced a number I. What is mean by I? Can't have factor. Okay. Okay. Right. Up to this formula, up to here you write. Up to here you write. We will do one question. you followed the steps that we did here? Next. Okay, done? Ida? Okay, done? See, the experimental method or instrument that is used to calculate RLVP is called Walker's apparatus. What is it? Walker's apparatus is used for measuring RLVP. Remember this line, Walker's apparatus. Ostwald's Walker's apparatus. Intama? Chi A means what? Number of moles of A by total number of moles. Number of moles of A enta 10. Total number of moles enni 10.1 ఎట్లా వచ్చింది? Done everyone? Don't write all this theory, just write this instrument name. Done. Okay, next. Okay, there are many questions we can solve after completing this session otherwise. So the next one is what? Elevation in boiling point. See, elevation in boiling point means, let us see. Look at this graph, ma. See what I have taken here? Vapor pressure. Okay, and here I am taking temperature. See, elevation. So what happens? Increases. In what? Boiling point of solution get increased by addition of non-volatile solutes. What I am adding? Non-volatile. See, RLVP lo em chesinam amma? To the volatile solvent we have added non-volatile solute. Here also to the volatile liquid what I am adding? So now what happens in that case? Vapor pressure increase avutuda, decrease avutuda? Lowering of vapor pressure we have studied. Vapor pressure is decreasing means what about its boiling point? Increases. So look at this. Solvent vapor pressure is like this. It means this is the temperature at which its vapor pressure is equals to 1 atm. Can I say this is the boiling point of pure solvent? So what do we mean by boiling point? Boiling point and definition enti? The temperature at which vapor pressure of that liquid is equals to atmospheric pressure. Once again, what do we mean by boiling point? The temperature at which vapor pressure of that liquid equals to atmospheric pressure. See, if this is a atmospheric, for example, this is the atmospheric pressure. Okay, so now I am increasing the temperature like this. So now what happens? I have a liquid here, increasing the temperature like this. So slowly it converts into what form? Vapor form. So this is a point where the vapor pressure of this liquid will be equals to atmospheric pressure. So what I can say this temperature as? Boiling point of that particular liquid. So T naught of that solution, T naught B. T naught means what? Pure solvent boiling point. So now what happens? I am adding a solute to this. This is what? This is for solvent. So దీనికి మనం ఏం యాడ్ చేస్తున్నాం ఇప్పుడు? So if I add solute, what happens to its vapor pressure? Vapor pressure ఏమవుతుందమ్మా? Relative lowering of vapor pressure we studied now. So vapor pressure decreases when you add non-volatile solute. So if vapor pressure is decreasing means what happens to boiling point? So the boiling point will be seen something like this. So this line is for which one? Solution. So this temperature is for what? Boiling point of solution. Initially this is a boiling point. Now it is moving here. It means this difference is there now. This is what? Elevation in boiling point. Initially let us say 100 degrees. Now it is becoming 102. Increased or not? Boiling point of water is 100 degrees previously. That is solvent. Now I am adding a glucose to this non-electrolyte, non-volatile solute. What happens to its boiling point? Increases from here to here. So the difference is called as what? Elevation in boiling point. What is that? Elevation in boiling point. So this, how much temperature is increased, how much temperature is elevated, how it will be calculated, this is directly proportional to the quantity of solute you are adding. What we are adding? So that is given in terms of molality. What is that? Molality. And I told you about I value, Van Hoff factor. If more number of ions it is generating, more will be the particles. More particles, more colligative properties. Means here also you should indicate symbol I. So what is the use of I? Van Hoff factor. Number of particles are given with that I. So remove this proportionality. Delta TB equals to, you remove this and keep it as a KB into I into M. So MI. So what is this KB here? It is KB is called a constant. So particularly you should call it as molar elevation constant. What I am saying? Molar elevation constant. What is that? Molar elevation constant. Once again, what is the formula you got? Delta TB equals to IKBM. So delta TB and enti, this is a difference right now. What minus what? TS B minus TS naught IKBM. So this is the final formula you write. So what do we mean by M? Molality. What is that? Molality. Write these formulas. Okay. We'll do 1 or 2 questions, then it will be easy, then understanding the concept, I think. See, ఇంకా జనరలైజ్డ్ ఎగ్జాంపుల్ చెప్పాలంటే ఇంట్లో మనం రైస్ చేస్తాం కదా, కుకింగ్ రైస్. సమ్ టైమ్స్ రైస్ వోంట్ బి కుక్డ్ ప్రాపర్లీ. వాట్ యువర్ పేరెంట్స్ విల్ డూ? దే విల్ ట్రై టు యాడ్ సమ్ సాల్ట్. హ్యావ్ యూ అబ్జర్వ్డ్? Add These formulas done? Write a question, everyone. Question by Namokar. 0.9 grams of urea is added in 45 grams of water that caused elevation of 0.17 degrees Celsius in boiling point. Calculate molar elevation constant. What they are asking to calculate? It means what is that molar elevation constant? Kb. So now see, this caused elevation of this much. So what is the elevation in boiling point value? 0.17. So now what is the formula we have? Delta TB equals to I Kb M. Okay. See, urea is an electrolyte or non-electrolyte? See, it's a non-electrolyte. So generally you consider organic compounds are non-electrolyte. Okay. So urea formula you can write CO NH2 NH2. Will it dissociate into ions? So it's a non-electrolyte. So for all non-electrolytes, non-electrolytes, I equals to 1. So wherever you have I, put it as 1. Okay, delta TB value how much? 0.17. Okay, next one, what they are asking? Kb value. So Kb they want. And what about molality? Did they give in molality value? So how can you write molality? See, 45 grams of water they are saying, 0.9 grams urea. So what is our solvent and solute here? Urea is solute, water is solvent. So what is our definition of molality? Number of moles of solute in 1 kg of solvent. So can I write number of moles of urea dissolved in 1 kg of solvent? They are given in the grams now. So weight of solvent, water in grams multiplied with 1000. Can we say like this? So number of moles means what I can write again? Given weight of solute by molar mass of solute into 1000 by weight of solvent. Okay? Yeah. So tell me what is the values they mentioned? Weight of solute how much? 0.9. Molecular weight of urea? 60. How much? 60. Calculate using that. 1000 by what is the weight of solvent mentioned? So try to simplify. 0 is removed. So this 0 if I remove, so 9 it becomes 90 I can write. So this many times? 2 times. Next 0 already removed. So this is 3. Here how much we have? So Kb by 3 means can I send 3 this side? So Kb becomes how much? 0.17 into 3. So 0.51. So what is the molar elevation constant? 0.5. Write it fast. Okay. So what we discussed once, tell me. Colligative properties 2 are done. What are those? RLVP, elevation in boiling point. Next, azeotropic mixtures. Before that, non-ideal, ideal solutions, Raoult's law. Okay, remaining 2 colligative properties are there. Evening class will be completed.